Before we really get into or talking about RBAC, it's important to understand all of the stages of a request into the API. So this diagram is taken from the URL you see below, and it basically illustrates all the stages of the request. The first is you have to establish a TLS connection. Once you've established that, then we have to get authenticated. And we'll talk about authentication and all of the authentication modules in a minute. But once you're authenticated, then you walk in through authorization. And once you're authorized, which is what we're going to be talking about is RBAC a little bit later, then the admission control modules fire. If you're not familiar with those, they're bits of code that either modify or reject requests. So a simple example is the always pull image controller, which really does what you think it might do. It forces an image to always get pulled. Then once those all fire and you don't get rejected by the admission controllers, then your request goes into the API. So Kubernetes authentication. API requests are tied to either normal users or service accounts. Normal users are managed by outside services. So Kubernetes doesn't have really the concept of a user, while they do have concepts of service accounts. And so you can run pods under service accounts, and that's the use case there. Otherwise, the calls are anonymous. Again, Kubernetes will use one or more authentication modules to authenticate. So there are authentication modules for client certificates, bearer tokens, authenticating proxies, or HTTP basic auth. We're going to be looking at using client certificates in our demo. So here's kind of a snapshot of the documentation. We can actually just go out to the documentation here and have a look at it. The authentication, all this documentation is quite good. So I would highly urge you to walk through here and walk through each of the authenticators so you can gain a better understanding. I'm going to give you a very high level understanding, but then I'm also going to walk you through a demo of creating a certificate. So the authentication plugins, they all attempt to associate the following attributes with the request. At the very least, they try and return back a username. There's also this concept of a UID, which is supposed to be a more unique version of a username. Some of the modules will return groups, and then others can produce extra fields for you as well. But all of them attempt to give you back this opaque username. So what does that mean, opaque username? Basically, it means that those fields, really, the authentication system doesn't really know anything about them. They're just opaque values that only really have significance when passed to the authorizer. So the authorizer gives them some meaning. So you're going to get a username passed to the authorizer, and then the authorizer will then determine whether that user has the ability to perform whatever you wanted them to perform. So as I mentioned, what we're going to do in our demo is we're going to create an X509 certificate, and then we're going to put it in a Kubernetes config file, and we're going for a new user, and we're going to allow that user to authenticate. And then later on, when we start talking about RBAC, we'll give that user some permissions. So the X509 certificate is going to be supplied with the call, and it contains the certificate authority. If it's verified, the common name, the CN, is used as the username, and the O is used as the groups. So the easiest way to kind of walk through this is to go through a demo. We'll create a user, we'll create a certificate, and then we'll create a Kubernetes config file. And once we have that file, then we can go ahead and at the very least make a connection to our Kubernetes server. And a little bit later, we'll add those permissions in. In this demo, I'm going to create a Kubernetes config file for a new user. In order to do that, we need to create a certificate signing request. We're going to pass it into Kubernetes to its certificate authority and ask it to approve that signing request. Then we're going to pull that certificate back. Once we have that certificate, we can cruft up a Kubernetes config file. Seems like a lot of work, and so to that end, I've created a container or an image that will allow you to do that. So if you go out to github.com, whack Rob Bagby, whack Kubernetes Cert Creator, you'll find all the instructions on how to use the Docker image. You've got all of the instructions here. I'll walk you through some of the specifics. What we actually do inside of the container is we use OpenSSL to create a PEM and a CSR, our certificate signing request. Then we create a YAML file. That's the format that Kubernetes wants that signing request in. And then we call kubectl create on that to create that certificate signing request inside of Kubernetes, and then we ask Kubernetes certificate authority to approve that. Then we go ahead and pull that certificate signing request, the approved signing request back, and we pull out the certificate, and we use that to craft up a new Kubernetes config file. If you want to see the specifics on how it works, you can go into create cert.sh and take a look at all the actual commands that are getting run. Now, the next thing I can show you is the guidance on how to run this. And so this runs, if you're running Docker for Windows, you can run it just fine, and it's almost exactly the same. I haven't put the guidance up yet, but I will. But really the only difference is going to be the format of the volume mounts from Windows versus Linux or a Mac. So you're going to I'm going to use this exact example, Docker run. I'm going to tell it to remove itself when it's done. And then I'm going to map 3 volumes. The first volume I'm mapping is to the file, the ca.cert. That's the certificate authority certificate that we're going to pull from our Kubernetes cluster. And this certificate's required in order for us to make a TLS connection to our API. So we're going to map that into this exact location. And then we're going to go ahead and map this volume. And by the way, you'll change this directory to wherever you pull that ca.cert file to on your local machine. I'm going to show you how to pull that down in just a moment. Then we map a volume to the output, whatever directory, to this wax certs directory. And that's where our container is going to create all of the output files, including the Kubernetes config file that we want. I could have written it out to standard out, but I wanted you to have all the files and the certificates. So I chose to do it with a volume mount. And then you map a volume from the actual file, your Kubernetes config file, that has the authority to create signing requests and approve them. And you're going to map that into this specific location inside of the container. And that's going to allow the container itself to go ahead and make those calls into our Kubernetes API, the kubectl commands. Then we have to pass 4 environment variables. The username that we want to create, in this case I'll call it test, any groups you want, and they're in the format of wacko equals group name. The cluster name, this is going to be the cluster name inside of your Kubernetes config file, so this can really be anything. And then the server URL. This is the URL to your server, to the master node itself. If you want to figure out how to find what that is, if you go into your cluster, I always sort by type and look at the public IP address for your master. That's the DNS name right there, or you could use the IP address. I use the DNS name because it's stable. And then this is the image that we're creating, RBAC BWAC Kubernetes Cert Creator version 0.1. Okay, so before we can run this, I need to do a couple things. I need to bring down that Kubernetes config file locally, and then I need to be able to pull in that CSR file, or excuse me, CRT file. So with that, let's go ahead and bring in our Kubernetes config file. So I've got a couple terminals here. I've got one to an input directory and one to an output directory, and these are the two directories I'm going to map into that container. And I've gone ahead and done an ls just so you can see that they're both empty here. Now I'm going to go ahead and I'm going to paste in the scp command to pull back my Kubernetes config file. Okay, my config file's been brought down. If I do an ls.kube, we can see that that config file is there. And if I do an ls.lart, we can see that this thing, well, actually you don't know when I created this thing, but this was just created just now. So the next thing we want to do is bring back that ca.crt, and I want to put that in that input directory. So that's going to be in this directory here. Again, there's nothing in there right now, but if I do this scp command back to my bagb default network dot blah blah blah, it in etc Kubernetes certs, you'll find the ca.cert file, and I want to map it into this exact directory inside of my, or excuse me, this is where I'm copying it directly onto my file system. Okay, let's do an ls. And you can see we have our ca.crt, so we're all good to go here. Okay, again, still nothing in our output directory. So let's go back into our guidance, and let's grab that docker run command and let's run it. Okay, so again, you can see I've mapped those volumes. These are the volumes to that input where my ca.crt is, where I just copied it. I've mapped the output directory that I want to get my search created in. I've mapped the kubeconfig file that you saw me just copy down over to root.kubewhackconfig. I want my new user's name to be test. He's going to be part of the deployers group. The cluster name is going to be the name inside of my kubeconfig file for this cluster, and this is the URL to my server. So let's run it. So I was unable to find this. We have I copied things improperly there. So let's go back out here, and I will copy that into another location. So let's see if this works a little bit better. Okay, you can see that I've fixed that up. I'm not sure where those other commands are coming from, but we're going to see the container do its work. First, it's creating the certificate. It's got that certificate. It pulled the certificate out. Well, it created the signing request, pulled that out. Then it created my certificate called config for my test user, setting the cluster name in there to the cluster name I asked it to, set the credentials, set the context name, and then told it to use the current context. And it said my new kubeconfig file is in whack-certs whack-config-test, which I mapped over to this directory. So let's just do an ls here. And you can see that we have our config-test, including all of our certificate signing requests as well as our certificate. And so now I can do this. Let's do export kubeconfig equals, and then let's set that to be our config test. Great. Now let's do kubectl get pods. Well, that might look like a bad message. This is actually a good message. We got an error for the service. Pods is forbidden. User's test cannot list pods in the namespace default. So we were able to create a TLS connection into our server. We were able to get authenticated, and because we don't have any rights assigned to us, we were denied the ability to do the command we wanted, which was get pods. So in a later demo, we'll show you how to set up the rights so that we are able to get pods. Okay, now that we've created a user that can authenticate with our cluster, we can get into giving that user some authorization. So for that, we're going to use RBAC. So RBAC seeks to answer the following question: can the subject do a specific operation on a specific object in a certain context? So for example, can user Rob list pods in the whole cluster, or can group creators create pods in a specific namespace like namespace 1? So RBAC authorizes based on the roles of the users or groups. Access is granted to roles, and then the users or groups are associated with those roles. There are 4 base types that you'll be working with in RBAC. There's the role and cluster role, and role binding and cluster role binding. So the role and cluster role, those are the rules that represent their permissions. So permissions are additive, so there are no deny rules. They're only rules that tell you what you can do. So the difference between roles and cluster roles is that roles are defined within a specific namespace. Cluster roles are applied to the entire cluster. But the interesting thing about cluster roles, and what people don't initially understand, is that you can apply them either cluster-wide or per namespace. Meaning you can create a cluster role that's applied across the entire in the entire cluster, but then you can create a role binding that binds a specific user to that cluster role in a specific namespace. And for that reason, they're much more useful than roles. As we're going to see in a little bit later, the typical use case is you typically use cluster roles to define most of your roles, but there are patterns where perhaps maybe I'm going to set user X up as an admin in a specific namespace, and I'm going to allow that user to then create roles within that namespace. That's when you would use roles. But for the most part, when you're defining the roles of your organization, you would do those cluster roles, and then you could apply them in bindings. So here's an example of a role. This is a role called pod reader. You can see that it's bound to the namespace default, and it's saying that this role, pod reader, can get, watch, or list pods. Cluster roles, really not a whole lot different than roles, other than you give it the name, the kind of cluster role, and you don't associate it to a namespace. Again, I can apply this cluster role to a specific namespace in a binding. So here's what a role binding and a cluster role binding look like. So this is a role binding, and you can see that it's taking the role of pod reader, and it's binding user Jane to that pod reader, and it's doing it inside of an object named read pods, and this is being bound in the namespace default. Now at the very bottom where it says role ref, that kind could be a cluster role just as easily, and it would still be able to be bound into that namespace default. So let's go into a demo, and we'll create some permissions, and we'll see what happens, and I'll show you that use case that I was talking about. Okay, we're back in the two terminals we had. Remember, on the terminal right, I have my I've got my config test that we're using set up for me, so I don't have the authority to do things like get pods. Okay, now if we go over to the left, if I go over to this terminal and I do export kubeconfig equals, and then we do that to the admin, and we do kubectl get pods, you can see that although we didn't have any resources, that was able to work. So let's go ahead and I'm going to move over to another directory. Where I have some RBAC files. So let's just do an ls and take a look. So we've got a cluster role pod reader, and so let's take a look at this whole directory here. So I'm going to bring up Visual Studio Code as my code editor. I'm going to take a look at all three of these files, and we'll start with the cluster role pod reader. So we've got a cluster role. Again, this is applied to the entire cluster. It's called pod reader, and we're going to go ahead and say that for the resource pods, you're able to get, list, and watch them. So you're not able to create pods. And then I have a cluster role binding, which binds the user, my user's test that I just created, to that cluster role that we just created. Okay, so let's go ahead and create those and see the effect of that. So let's do a kubectl create -f cluster role pod reader. Okay, so that cluster role is created. And let's do kubectl create cluster role binding. We need a -f. Okay, so that was created. So now let's go over here and try and get pods. So kubectl get pods, and we can see no resources found. So we didn't get forbidden. However, if I did something like kubectl run nginx image nginx, you're going to see that we're not going to have the permission to do that. So we would have to add that permission in. So that's all well and good. That illustrates pretty clearly how you can use cluster roles and role bindings, or cluster role bindings in this case. Let's talk about the use case we talked about earlier, where you might want to create a namespace and then give somebody the admin ability in that namespace, and then they might want to be able to create roles. So we can illustrate that by doing this. If we go back over to our code and we take a look at test admins, we can see here this is a role binding. So it's not a cluster role binding. So I'm taking a role binding and I'm tying the cluster role of admin to my user's test inside of the namespace test. Okay, so here's where we're taking a cluster role and we're tying that over to a user, and we're doing that in a role binding. So this is a nice illustration of what we were talking about. So let's do that. Let's do a kubectl create namespace test. Okay, and then we can do kubectl create -f, and then we'll do test admins. That's great. Now, if we go back over here to our user test and we try and do kubectl run, Still not able to because we're running inside of the default namespace. But if I did ---- namespace test, bang, the deployment was created. We can go ahead and take a look at the pods here. So we can do kubectl get pods. And you can see that the Nginx deployment, or that pod in this case, is running, although it was done as a deployment, and all is well. So hopefully this video has illustrated to you how you're able to both how RBAC ties into the authentication, how the user and then groups are then passed over to the to RBAC, and then how you're able to use roles and cluster roles and role bindings and cluster role bindings in order to give those users or groups permissions, as well as hopefully you understand now that you would typically use cluster roles at the aggregate, and then if you gave somebody, say, admin inside of a namespace, then you could allow them to create roles within that namespace. Hopefully all that's been very helpful